Hi, and welcome to the Catalyst workshop on Data Testing Lab. To start from, let me introduce myself. My name is Sergey, and I'm author of the Catalyst framework. During my deep learning research experience, I was always looking for a tool for quick prototyping, research hypothesis testing, and hyperparameter search. And after a few years with Theano, TensorFlow, and Keras framework, I finally found PyTorch 2 years ago. PyTorch is a great framework to create deep learning models and pipelines. Nevertheless, for all its merits, it could use improvements in terms of writing train loops, validating, and testing neural networks. Moreover, from my own perspective, for real breakthroughs in deep learning, we as a research community need a strong foundation. We need a tool to gather all deep learning knowledge in one place. And here we come to the Catalyst. Catalyst is PyTorch high-level framework for deep learning research and development. It focuses on reproducibility, rapid experimentation, and code value to use, so you can create something new rather than write another regular train loop. During 2 years of development, Catalyst was tested in a large number of machine learning projects from both academia and industry. In addition, all these projects have covered various fields of deep learning: computer vision, natural language processing, generative adversarial networks, or even reinforcement learning. As a result, the framework is designed to be extremely extensible and production-friendly while making state-of-the-art deep learning engineered tricks like half-precision training, distributed training, or something like trivial for user. Catalyst tries to solve four main challenges of recurrent deep learning. The first one, reproducibility. All Catalyst-based pipelines are fully reproducible, even on different hardware parts, with Docker support, of course. Second one, scaling. With Catalyst API, it's easy to train neural networks on single GPU or large Slurm cluster without any code change. The third one, experiment tracking. Catalyst automatically saves all necessary code, metrics, and model checkpoints during training, so it's easy to recover best experiment during large grid search. And the last one, collaboration. With Catalyst high-level API, it's much easier to discuss your ideas because of small amount of required code base. Catalyst team and contributors consist of individual and academia researchers, Kaggle master, and professional software engineers. Moreover, you can check out Catalyst-based Kaggle competitions, pipelines, projects, and even frameworks on the GitHub page. That being said, let's go to our speakers for this workshop. Our first speaker will be Kirill Vishnikov and his success story on using Catalyst with Kaggle and academia project. Kirill is only a student, but already has Kaggle experience and open source project contribution. He shared his CatMix implementation with Catalyst community. Our next speaker will be Lakesh Nandanwar, graduate research assistant at University of Malaya, Malaysia. During his talk, he'll present his research on multilingual text detection in video and images. While main research methods are working only on a few languages like English or Chinese, his research is focused on other languages like Hindi, Russian, or Arabic. After that, Hristo Rogazov, senior machine learning engineer, will discuss his experience on multitask learning in real world with Catalyst. Hristo is also a creator of DNNCool, which means Deep Neural Networks for Conditional Objective-Oriented Learning framework on top of the Catalyst. I hope he'll also mention his friend in this talk. Our next speaker will be Yuri Kashnitsky, senior machine learning scientist, NLP practitioner, and PhD in applied math. His talk will be addressed to benchmarking such advanced deep learning architectures such as BERT to typical baseline logistic regression in the field of text classification. Continue the topic of natural language processing. Anatoly Potapov, a machine learning engineer from Tinkoff Bank, will introduce his transformer pre-training pipeline with half precision training and Slurm support. I hope this presentation will be a good introduction in training large neural networks at scale with Catalyst framework. Going to another topic, Alexey Shabanov, deep learning engineer and PhD student, will give an introduction to the metric learning pipeline on Catalyst. Thanks to Alexey, Nikita, and Julia, our metric learning team, we have integrated advanced metric learning practices directly to the Catalyst framework, so you can easily reuse our experience. After that, Nikita, our metric learning team contributor and MAPT student, will give a talk about his research on lottery ticket hypothesis and pruning. In this talk, you will learn how to make a neural network more accurate without any tricks, or maybe only a few. Next speaker, Alexander Ivanov, machine learning engineer from Tinkoff Bank, will present his pipeline on advanced style transfer with Catalyst. During his presentation, you will learn why experience monitoring really matters during style transfer evaluation and how Catalyst could help with that. Last but not least, Evgeny Kachan, our core Catalyst developer, will present his pipeline on super resolution with generative adversarial networks and Catalyst framework. In his presentation, you will learn how to zoom your images like a pro without image quality issues. I hope you enjoyed our speakers and now can see Catalyst framework from different perspectives. If you have any questions about the Catalyst workshop, feel free to write me anytime. Thanks for watching and see you in the workshop.